For today, we are going to learn about the Cramer's rule. It is a method to determine the solution of linear equation system. Remember that we can write our linear equation system in form of matrix. This is matrix A, consists of all coefficients of your linear equation system, and then the matrix X consists of all variables of your linear equation system, and matrix B, which is the solution of your linear equation system. Or you can also write it in form of augmented matrix. It means you combine the matrix coefficient and also the matrix B all together, and you don't have to write the matrix X. Consider the following example on the right side of your slide. This is how we can compare how to write the linear equation system in different form. The question here is how to find the solution of linear equation system, or in other words, how to find the x1, x2, x3, etc. Or if you say it is an x and y and z, that's up to you. According to Cramer's rule, if Ax equals 2b, a system with n linear equations with n variables, then it has a unique solution if the determinant of A is not equals to 0. The solution then can be found by using the comparison between determinant of Ag with the determinant of A, where Ag is the matrix constructed by substituting the entries of column G of A with the entries of matrix B. Let's consider this example. Suppose that we want to find the solution of the following linear equation system. First of all, check the matrix of the linear equation system. You can see that matrix A will consist of the row 1, 0, since the first linear equation system has the coefficient of 1, 0, and 2. And then in the second row, we will have 3, 4, 6, and in the last row, we will have negative 1, negative 2, and 3. And then we can create the matrix B as 1, 9, and 4. After that, check for the matrix AG. In matrix A1, we substitute the entries of first column of A with the matrix B. So we substitute 1, negative 3, and negative 1 into 1, 9, and 4. In matrix A2, we substitute the entries in column 2 with the matrix B, and then in third matrix or A3, we substitute the third column with the entries of matrix B. After that, we check all determinants of the matrices. You can use the column or row expansion to check the determinant of A, determinant of A1, determinant of A2, and determinant of A3. After you get all of the determinants, find the solution. For instance, to get the value of x1, you can divide it the determinant of A1 with determinant of A. Since the determinant of A1 is equal to negative 44 and the determinant of matrix A is equal to 44, then the x1 equals to negative 1. Continue the process and you will get the x2 equals to 0 and the x3 equals to 1. Do you get how the Cramer's rule works? To be sure, in your book, let's try to solve this linear equation system by applying the Cramer's rule.